One of the most fundamental assumptions in our experience and in science is that all observers must see the exact same thing happen. After differences such as relative movement, perspective, or distance are accounted for, we chalk up the differences as mere appearance, all driven by a single underlying reality. For example, if the IK Pegasus binary star system, which is about 150 light years away, goes supernova, as astronomers predict, everyone in eyeshot will see it, eventually. Wicks on the planet Kosu orbiting IK Pegasus will see it almost immediately, albeit for a fleetingly short time. For Wicks, it will be a cataclysmic flash. Here on Earth, my great fifth granddaughter will see it as a bright star in the daytime, where there was none before. It will inspire her to travel on the first colony starship to the nearest habitable planet. And our far distant descendants, who have evolved into beings of pure dark matter, and who have traveled to the far reaches of our universe, will get to see it again and again and again, if they so desire. They will see it as a dot of light in a museum piece telescope, for the sake of nostalgia over landmark events. Granted, the scenario is pure fiction, but one can dream silly dreams, especially about the future. In Big L life, which is human reality, dreams have an important place. They are the possibilities upon which our actuality is built. They are the potential answers to nagging questions. So here is a $64,000 nagging question. How do we explain this sameness of observation, this unity of experience, this objective reality which was alluded to in the first video? This question has floated to the top now that we no longer presume an existing big R reality. In other words, we no longer have a single theater from which we can all observe the goings-on, to map our world onto. And keeping with the water theme, physics has no safe harbor in which to weigh anchor, even if it seems calm now. Instead, it is a calm before the storm. We have been cast adrift without really realizing it. We know that something's wrong, that something is missing, but we can't quite put our finger on it. Please bear with the obvious water metaphors. It is a segue to the main point of this video. It will be a main hypothesis of this video that in order to solve this question, we will have to understand reality as a process, as an ongoing event, which is in line with the main theme of the current set of videos, the occurrence of events. Furthermore, at its next underlying level, reality is a raging river. Or better yet, the whole friggin' water cycle. The same of which literally cannot be stepped into twice, as the philosopher Heraclitus proposed. This does not bode well for laws. Laws require a somewhat static, underlying dead world to reside in, something that does not change, something that is a given, something we can hang our hats on. If we go with this hypothesis and discard our hat rack, a hard riddle is created, a missing piece. How can something so dynamic and complex underlying everything be so flawlessly consistent among different observers, an occurrence which we take for granted? For example, compare the Large Hadron Collider, which has millions of parts and an advanced computing system, to a simple magnifying glass, which may only have a few parts, if that. Any guess on which is more reliable, which you would bet your life on to perform flawlessly? And yet our universe is always right, always perfect, as far as we can tell, never giving an inconsistent answer between different observers. That is a riddle based on a question, based on a model. We must address this conundrum if we are to make progress, regardless of whether the main hypothesis of these videos are correct or not. Before jumping into the primary topic of this video triplet, which explores the occurrence of events, we will lay a little groundwork. First, we will refine the dichotomy between big R reality and little r reality, a little more. And second, we will examine how the two competing views of reality and physics answer the question of how different observers can see the same thing. One is based on Einstein's relativity, and the other is grounded in quantum theory and its interpretation. By the way, the subject matter about events needs to be broken into 3 videos to get a little more wiggle room for physics' double vision of reality, among other things. Or maybe, as some close to me believe, it is because I like to hear myself talk. So let's get to the first point, the distinction between big R reality and little r reality. Even though the first set of videos are devoted to defining little r reality, and a later video will focus on big R reality, It can't hurt to firm up the tofu a little bit. The distinction between big R and little r is probably one of the easier metaphysical concepts to understand, even though it is not taught explicitly in your basic philosophy class. Distinctions are the bread and butter of philosophy, the way clarity is achieved, like clarifying butter or splitting hairs. It is probably one of the reasons people get a little frustrated with the endeavor, myself included. Despite its bad rep, analysis can be a useful tool if used judiciously, just as reduction is useful in scientific pursuits as long as the facts support it. At its most basic, big R reality can be thought of as a container in which all real things reside. However, when I say container, I'm not referring to a container as a real solid physical thing. It is not like a big fishbowl with an inside and outside. It is more mystical than that, to coin a nonsense word for fun. Instead, big R, being godlike, is infinite, singular, and unlimited in both space and time, at least in this moment of our mental evolution. Stick a pin in this point. Briefly, using space and time to define big R reality is something that we will have to take a serious skeptical look at later on. Finally, big R reality has no outside, only an inside. In short, it is the background in which all real things exist and happen. Just a reminder, as I mentioned in the first video, big R has been court-martialed. It should no longer be considered an existing object. As such, it might be more accurate to describe what I once called big R reality as infinitely unreal. In fact, I like the idea of swapping out incandescent light bulbs for LEDs. So from now on, I will no longer use the term big R reality when referring to this demoted form of reality, which does not exist and cannot exist by definition. Going forward, I will refer to it as the infinite unreal. An echo effect would have been nice, but that was beyond the production budget. I tried, but I couldn't come up with a better term. We don't seem to have the appropriate word or words to convey the concept as it is put forth here. I could have relied upon the term Parmenides coined so long ago. He called it the void. However, that has too much baggage. He understood that the void did not exist, but he couldn't live with the paradox that having a non-existent void created. As a side note, this mental adjustment to the way we look at the container is not a step forward in the resolution between quantum theory and general relativity. It is an undoing. It is an opening of our eyes so that we can better see a resolution. It is important that we discard this Western myth and its remnants. It has insinuated itself into our consciousness over the last 2 millennia. It appears as a hidden assumption when we ponder such questions as, is reality really real, or does infinity exist? It is sometimes necessary to take a step backwards before taking a step forward, and we have a big revolutionary step forward to make. In stark contrast to the infinite unreal, little r reality does not need to be redefined. We have intimate experience with it every day of our lives. It can be thought of as the sum total of all real things that reside in the infinite unreal. And unlike the infinite unreal, which must be singular, real things include an unimaginable multitude and variety of objects and events causally connected in myriad ways. Examples of objects that reside in the infinite unreal are quarks and galaxies. Size does not matter. More specifically, a quark is no more and no less real than a galaxy. In other words, realness is an all-or-nothing proposition, independent of size. Also, the fact that an object is composed of parts does not detract from its realness. In principle, having parts is an essential part of what makes an object an object. Correspondingly, being a more fundamental object does not make an object that much more real as some would maintain. An atom is not more real than the dog, which the atom composes. Logically, a fundamental object, an object without parts, is a contradiction in terms. And it is where the definition of an object can become gray. A tornado is an example of a borderline object with pseudo-parts. Again, as long as the object resides in the infinite unreal, an object is real, no matter its size or composition. Realness is not a qualitative property like redness or silliness. Just like objects, events are real. One example is the collision between the electrons in my fingertip and the plastic key for tea on my keyboard right at this moment, which has flown into the past by the time I finish writing this sentence. And like objects, events can be comprised of parts. Take a complex event such as a carnival. It can be broken into many sub-events, such as the sideshows, games, and the rides that happen within the carnival. Then we have the oldest event of all, the Big Bang, which many see as the, in capital letters, fundamental event, which created everything, space, time, existence, and the building blocks of all real things. There it is again, the word fundamental, based on the word fundament, which means foundation, or a person's tailgate. I am not sure how the different meanings are related. I guess that is one more thing to ponder as I sit here on my fundament. And that is where we get into trouble. And it is probably one of the other reasons physics has gotten itself into a little bit of a pickle. We are trying to lie in our cake and eat it too. For example, if the infinite unreal is truly infinite, how could it have a beginning in time? That would denote it has a boundary, at least in one direction. Boundaries are another hallmark of existing things. Additionally, if there is a boundary, what happened before the Big Bang? Or is that even a valid question? How can the infinite unreal share a defining property, a boundary, with real things? These are just issues that will have to be addressed when the moment arises. At its core, however, the questions highlight what happens when little r reality begins to tug at the infinite unreal and vice versa. If I'm reading the tea leaves correctly, this tug is a sign that something needs to change in our conceptual framework of the universe. Something is messing with our picture, and we need to adjust the TV set. Despite the metaphysical conundrums that theoretical physics is trying to resolve, or at least live with, the distinction between the infinite unreal and little r reality can stay in place. Again, seemingly paradoxical statements will be made. Specifically, how can a non-existing thing such as the infinite unreal make something real? Frustratingly, that will have to wait until a later video. For now, it will have to be an assumption, a given which must be accepted as a ground rule in order to attend the buffet. And if you aren't frustrated yet, here is another paradox that might drive you over the proverbial edge. If we try to make the infinite unreal real, it becomes subjective, which is another paradox that has driven many a thinker bonkers throughout history. Maybe that is why philosophers like to cook up mental heartburn, to hide their own angst. Hopefully, this quick discussion adds enough substance to what was glossed over in the first video, which centered on the existence of objects. It will allow us to proceed with better footing. One final note about containers and the contained, and then we can look at the second point about how physics currently addresses the unity of observation. I have purposely avoided a precise philosophical definition for an object and an event, as well as the infinite unreal. Although I alluded to some of their features, such as an object or an event always having parts and boundaries, I don't want to get bogged down in dry discussions, such as whether a ship which had all of its planks replaced is still the same ship. We all have an idea of what an object and an event are, and we use those concepts in our everyday life. We may make mistakes, but hey, that's life. Besides, our notions of objects and events are evolving things with gray outlines. They are not absolute, cannot be absolute. We shouldn't try to nail something down that likes to move. Also, I didn't want to open the door at this point into the argument over the circular nature of the two forms of reality, which some, might see as a red flag. For example, how can something be contained if there is no container? Likewise, if a container does not contain anything, is it truly a container? See what I mean? However, circularity is not necessarily a bad thing, especially when it comes to pulling properties out of the infinite unreal to construct real things. In trade parlance, this is known as a teaser, by the way. In my younger days, I would have been happy to launch into a vigorous debate with anyone who was game. Older and wiser, I have learned to avoid questions that have no easy answer, and that give me headaches. And that is the amazing thing about this question over the unity of experience. It doesn't give me a headache. I think some light can be shed on it if we lay the groundwork that goes beyond what physics is willing to do and what philosophy has finally started to address. Maybe we can see what was previously unseen. Which brings us to our second pre-point of how physics currently deals with this unity of experience. And for that we have two positions, which have yet to fully meld. One is based on Einstein's relativity, and the other is based on quantum mechanics. If one is good, two is even better. Philosophy is not the only discipline that's got issues. Now I won't be able to get that song out of my head. In everyday life, which doesn't have to deal with the intricacies of physics or with the concerns of philosophy, the sameness of shared observation is so commonplace and obvious that we hardly think about it, or may not even be aware of it. We accept the difference in perspective, for example, as a matter of appearance without batting an eye. In fact, our brains have been softwired to account for it, to subconsciously see depth where none exists, to convert a foreshortened distance into actual distance, to convert appearance into reality. Correspondingly, we would not accept the world where the Pegasus supernova obliterated Wicks on Kosu, but my progeny on Earth saw nothing out of the ordinary. A world in which one event can and cannot happen, ignoring for now the quantum conundrum, is just not a possibility. And when we do become aware of it, such as when there is an unexplained discrepancy between what two people see, the fault is with the people and not reality. Reality would never stoop to deception or sleight of hand. It is not Descartes' evil genius. What we take for granted in everyday life, classical physics has made explicit and precise with the principle of relativity, which Galileo originally proposed, Newton refined, and Einstein extended. The principle of relativity says that the laws of physics must be the same for all inertial reference frames. That is what makes them laws. They are universal and independent of any observer. No one and no thing is above the law, especially physical laws, no matter the shade thrown at nature. I can imagine my daughter throwing shade at me right now for using the word shade. Given its common acceptance, the principle of relativity holds a unique position in physics. It is a meta-law, a law about laws, a higher law. Mother Nature is a firm believer in the rule of law. Maybe that is one of the reasons it is called a principle instead of a law, although it probably has more to do with its non-mathematical nature. Luckily for me, not all physics is mathematical. I do better with pictures. That Tahiti poster on my wall is calling. Precisely because the principle of relativity is formal and unambiguous, it shields scientists from having to address any underlying assumptions and their corresponding metaphysics. For example, it is irrelevant for physicists to ask if space-time is real. Special relativity is true whether or not space-time is real. Real schmeal. I had to dig deep for that picture. Peg one up for Occam's razor. As a workaround, we can just call space-time a theoretical construct that explains how time and space work and leave it at that. Although the issue can provide for entertaining coffee shop debates, or in our day and age, tweet storms. This point is not disparagement. There is little harm and gobs of good in adopting a principle that allows physicists to do their job, to build upon past achievements and to progress to great heights. It is much better to get work done versus sitting around arguing about whether tilt-up concrete panels or cinder blocks should be used to build an edifice. My wife is in construction. Don't ever let her catch you using the word cement to refer to the finished product concrete. With such a fundament, my new word of the day, much can be built. It is this principle of relativity along with the constant speed of light that Einstein used to mathematically derive the Lorentz transformations. The Lorentz transformations describe how space, time, and distant clocks shift when observers are moving relative to one another. It was a gargantuan and masterful feat. It was like building the Empire State Building with just popsicle sticks and Elmer's glue. Even though the principle of relativity is extremely powerful, it does rest on a metaphysical mountain, no matter what denials are made or dispersions cast. At the very least, it is metaphysical to deny the importance of metaphysics. Just because someone shouts with authority, "You shall not pass," doesn't mean that we can't go beyond. What fun is there in staying put and not challenging one's elders? Even if I am old enough to be an elder, it is time to get out of the house. If we go above and beyond denial and accept that metaphysics can come into play, there are a number of fundaments to be had. For instance, we could propose that we all see the same thing because we all sit in the same reality, in the same boat. And correspondingly, we are all in the same reality because we are all subject to the same laws, the same governance. The fates couldn't be more pleased. The fates, or alternatively Moirai in Greek mythology, control the thread of life for each mortal. They make sure the fate assigned to each mortal according to eternal laws is fulfilled, like our own personal fairy stepmother. To push the envelope even more, as laws go, reality follows. Laws determine reality, or even laws are the building blocks of reality. In this extreme view, laws have pushed out events as causal agents, which will directly contradict the main hypothesis of these videos. It doesn't get more metaphysical than that. Personally, I wouldn't go that far down the rabbit hole, and very few do. Instead, most play a game in which laws explain why things happen, but with the caveat that laws are not causes. This way of talking is just a matter of convenience, a convenient way to speak, to explain how laws work, to work around the inadequacies of human language. Why make a mountain out of molehills when everyone agrees that this is just a convention, a quaint way to impart scientific knowledge? Despite this convention under relativity's reign, there are some additional serious philosophical consequences that may or may not sneak up on us. Some that are overt interpretations, consciously proposed, and some that we tend to adopt without realizing it. The most common interpretation of relativity is to view the universe as a big block, where a moment in time is just another brick in the wall. In its most extreme interpretation, time is an illusion, and the universe is timeless. Every moment in time exists concurrently, just on different pages of a big, beautiful, deterministic, hardbound book, where the laws of nature have already scribed the entire book, all starting from an infinitely small watermark, the singularity. Reading the good book one word at a time is what creates the human experience and the illusion of a present moment. Our humanity jails us in the present like a photograph captures a moment. Consequently, in this universe, human words, which little our reality has heavily tainted, are not quite up to the task of describing a relative universe. The notion of past tense, present tense, and future tense is built into our language, like the notion of masculine and feminine articles is built into some languages. La forma de agua, and I apologize for my American accent. At best, human words can provide popularized summaries for public consumption. Human language only provides a shadowy view into the true nature of this reality, a slurred approximation of the world. Correspondingly, mathematics, the precise language that laws are expressed in, becomes the only true language of this timeless reality, the only tool capable of describing a nature beyond our quaint three dimensions plus human time. Mathematics is cosmos' expression of absolute truth. Likewise, physical models such as a large rubber sheet warped by large marbles to explain general relativity are seen as pretty pictures, analogies at best and fairy tales at worst, rooted in human illusion and shadow. Instead, geometry is presumed the better and truer representation of reality. Geometry is the canvas for the gods. Finally, a truth freed from reality's all-or-nothing constraint and rooted in mathematics tends to be seen as a property with gradations. In another word, like the recently coined truthiness. In this vein, more advanced laws are considered truer since they encompass and explain more events. For example, Newton's law of gravitation is less true than Einstein's general relativity, since it doesn't account for such phenomena as Mercury's deviant orbit or the bending of light around black holes. Even though precedent laws are viewed as incomplete because they approximate reality, that defect is always correctable with more precision. Smaller intervals of time, shorter distances, more truth. It is like resolving American football events with instant replay to get at what truly happened, to remove as much human bias, clumsiness, and imperfection from the equation as possible. Truth overcomes humankind's illusion of reality. Under this philosophy, which the principle of relativity encourages, truth is like Zeno's tortoise, which Achilles can approach closer and closer but never quite reach and pass. Alternatively, if we go all in and accept laws as the heir apparent to reality, we might believe that eventually a single final unified law will be found that explains all with absolute precision, like the answer 42 to the explanation of life, the universe, and everything. Glory be, we have light. Scientists can finally retire to Mount Olympus. Of course, I exaggerate into silliness, not to roast scientists, but to make a point. That being, we should not place laws on a pedestal and worship them. Laws are no more divine than any other tool, even if they have been extremely powerful and successful over the last few centuries. Laws have their limits, and finally, laws need not be the end-all, be-all of scientific pursuits. Sanctifying laws is like treating Einstein as a demigod when he was just a man, subject to common bias, imperfection, and frailty. Granted, traditional physics does not need any metaphysics and its attending modus operandi to proceed, and that is the beauty of the principle of relativity. It allows us to sleep in peace at night. However, when physics begins to rub up against its metaphysical foundations, or fundaments, as is happening now with such unforeseen and unexplained phenomenon as dark energy, That is when metaphysics becomes important to physics, when we should start to lose sleep at night. Unfortunately, physics, for the most part, has burned its metaphysical bridge after crossing it, and has been forced to take the long way back. Physics treats metaphysics like the embarrassing friend who is an obnoxious drunk. At drinks 1 and 2, he is very entertaining, but beyond that, his alter ego comes out, and he is sure to create a righteous scene. There must be a middle ground. Pause this video if you want to read the punchline to one of my favorite armchair philosophers. So along those lines, we will try to find a middle ground and rethink the roles of physics and metaphysics. In this picture, I'm not sure if they are passing a baton or if the tail runner is taking a picture, but the intended message is teamwork. It is time to summarize this little sliver of relativity as it relates to objective reality. Namely, the principle of relativity is a double-edged sword. On one edge, it has been an extremely handy tool for physics, and it provides a working premise about the unity of experience. On the other edge, its underlying philosophy has narrowed the definition of what is proper customary physics, and has hidden away what could potentially be seen. It has thrown up a roadblock. Even the great mind of Einstein could not find a way around. To paraphrase the saying, if all you have is a paintbrush, then everything gets painted, unless you see things differently. Two main themes throughout these videos will be that we should open ourselves to different tools and methods. Specifically, physical models should have equal footing to mathematical ones, and metaphysics can help provide a new base for the pavement currently under reconstruction. In this way, we can find a way around or through the current roadblock. That shouldn't be a problem. The laws of physics are not real and cannot physically hinder us like a real roadblock can. That is not to say that we can willy-nilly break the laws like we can with our human versions. We are not Wile E. Coyote who can walk on air until he discovers that he has run out of road. Just that the laws of physics are not causal like their human-produced brethren. It bears repeating. The laws of physics are not causal. In other words, the laws do not determine the future, even though they allow us to predict the future. It is as if they are constrained within a mirror dimension of our own making. That is why Achilles can pass Zeno's tortoise without breaking a sweat. I know. A later video will explain this apparent contradiction. I am getting ahead of the snow shovel. At this point, this is all just opinion and conjecture, maybe even wishful thinking. Feel free to disagree. All that I ask for is an open mind. The journey is in the spirit of adventure, of walking down an unexplored avenue, like floating down a river in an inner tube to see where it leads. Water, like life, always finds a way, especially when there's a logjam. Which brings us to quantum mechanics. Quantum mechanics was the way through the block that Einstein faced, even if he didn't want to admit it. So you see, Miss Ventura, sometimes when life shuts one door, it opens a window. So jump. To coin a corny line from the movie Made in Manhattan. And it did so by discarding deterministic laws in favor of tongue-twisting, non-existential, probabilistic ones. Say goodbye to the predetermined block universe. Say hello to the quantum realm. For example, a free electron cannot be said to exist in a single locale when we are not looking at it. Instead, all we can know for certain is that each finite space possesses a probability that the electron will be found there when we do look, and that finite space extends to the end of the known universe itself. The electron can be said to exist everywhere and nowhere, or, in Dr. Seuss's, I would not like them here or there, I would not like them anywhere, which doesn't seem to account as a material green eggs and ham existence. If anyone got upset over the loss of a single objective time and a single objective space, which relativity forces us to accept, they would definitely go ballistic over the loss of a single objective existence. Sometimes it feels like we are stuck in the middle of the Pacific with only a wet noodle for a paddle. What has physics done to us? Why can't we go back to the good old days of classical realism? However, we shouldn't blame the messenger. Physics is just telling it like it is. The fault lies with reality, who has become the ultimate trickster, since the job of evil demon was already taken. We will just have to make the best of it. Quantum behavior isn't going anywhere anytime soon, even if we cover our eyes, which seems to work for old-fashioned reality according to many quantum interpretations. So how does quantum physics explain the sameness of experience? This objective reality that stares me in the face when I look in the mirror and take a selfie. Like relativity, quantum physics takes a similar approach when it comes to its formalism. First, formulas mirror and match experimental facts. In the case of quantum mechanics, spectacularly. Second, powerful and accepted first principles are used to derive its theories and formulas. And third, interpretations are provided to fill in the formalism with some useful perspectives and to give context to the different quantum features. A free-form roadmap, if you will. Despite the similarity in how quantum physics and relativity are approached, the picture for quantum theory is not as simple as that for relativity. There have been a number of formal equations at different points in the evolution of quantum physics, starting with Werner Heisenberg's matrix mechanics, going on to Aaron Schrödinger's wave mechanics, consolidating some with Paul Dirac's transformation theory, and ending up at Richard Feynman's sum over histories approach, which is unique in its own right from the prior three. They are all compatible and all arrive at the same place. It is more a matter of deciding which is easier to use in a given situation, like selecting the proper tool for a given job. In computer science, this is a common occurrence, where any number of algorithms can derive the same result. At least it isn't like string theory, physics' prodigal child, which may have 10 to the 500th power potential solutions. Besides having multiple formal solutions, the picture for the interpretation of quantum fact and theory is fuzzy, a lot more so than relativity. Interpretations range from the traditional Copenhagen interpretation to the many worlds interpretation, with a lot of variations and variations within variations in between. Additionally, the consequences for each interpretation is very different, especially when it comes to metaphysics, ranging from reality as an illusion to many parallel existing realities that reproduce like bunnies. Rather than take in the full breadth of quantum physics, we will take a quick peek at the more traditional portion of it, the time-dependent Schrödinger equation and the Copenhagen interpretation. Remember, our goal is just to find where the explanation for object reality resides. We may bump up against other metaphysical principles, but our focus is narrower. First, let's look at the Schrödinger equation. Rather than get into the mathematics, which would be useful if we were planning to go through some student exercises together, it is probably best just to say what the mathematics define. In short, a wave. Not a physical wave, but more precisely a mathematical wave function. A wave function that evolves over time and that is spread out in space, like some weird vibrating string with infinite harmonics imposed on it. As if I have a whole bunch of tabs open on my browser, all playing different YouTube video songs, with a few Netflix and TiVo tabs thrown in for good measure. Initially, Schrödinger thought the spread out in space portion related to an electron's charge, which makes intuitive sense since an electron charge is physical. The best laid plans. Leave it to Max Born to get to the bottom of things. Instead of being physical, the wave related to something entirely mathematical. As it turns out, squaring the value of the wave function at any given point derives the probability of getting the measurement at that point. For example, if we are interested in measuring a free electron's position fired from a cathode ray gun through double slits, the wave function will give us the probability of finding the electron at a certain point, perhaps on a phosphor screen. Even if we were to do a deep dive, there is nothing physical or metaphysical here. It is all mathematical, despite appearing to have real-world consequences in space and time. So we have to look elsewhere. Perhaps the first principles of the Schrödinger equation can help us out. Pause as needed to see a moral first principle. Maybe they can provide some metaphysical guidance for objective reality as the principle of relativity did for Einstein's equations. Like for special relativity, there are two first principles, but that is where the similarity ends. The Schrödinger equation depends on the conservation of energy and the Born rule, named after its formulator Max Born, who came up with the probability scenario. There is no need to drill down extensively into the conservation of energy. That is old hat. It has its roots going as far back as the pre-Socratics, Thales of Miletus, and Empedocles. Glossing over a lot of history, mathematical advancements have been made when it comes to understanding the relationship between conservation laws and symmetries. Most notably, Noether's theorem, named after its discoverer, Emmy Noether. In our particular case, there is a relationship between the conservation of energy and the symmetry of time. In simpler words, what was true yesterday is true today. In addition, symmetries and conservation laws have been found that have jumped beyond classical physics and landed in relativity, particle physics, and quantum mechanics. All have even been found to depend on an even deeper principle, the principle of least action, of which I am a firm believer. Both Paul Dirac and Richard Feynman applied this principle in their formulations of quantum theory. Mind-boggling, to say the least. I wish I could say that diving deeper into more fundamental principles and laws is getting us closer to reality, but the opposite is true. Case in point, another mind-boggling idea is Adrian Bijan's constructal law, which explains how patterns evolve out of chaos in both inorganic and organic systems. Everyday instances can be found in the bifurcated pattern found in a river pan, a lung, and a tree, to name a few. These patterns can be formulated and predicted using this principle. Even hot miso soup can be seen to follow this principle in the way the currents and eddies blossom. The constructor law is the antithesis to the second law of thermodynamics, in which everything becomes the same law. To get metaphorical, it is how Neo and Agent Smith are antithesis to each other. The equations must be balanced. In effect, the constructor law fills a conceptual gap pointed to by those who believe that divine intervention is necessary for evolution. The constructor law defines a method to nature's madness. There is no need to wait around for a spontaneous Boltzmann brain to occur. Stated in as few words as possible, nature by its very nature designs stuff. The constructor law has yet to achieve universally accepted status like the principle of least action has. Still, it is interesting to see how a single universal principle can serve as a foundation for many disparate phenomena resting on different mechanisms. Despite the universality of certain principles, it doesn't get us any closer to objective reality and its metaphysics. Per Professor Bijan, physical mechanics is secondary to science in general, and to the constructor law in particular. Any system flow can and does follow the same primal constructor law. The constructor law can even be applied to abstract human endeavors, such as knowledge transfer from wise to young. It is universal in both nature and nurture. Not that Professor Bijan represents all theorists. However, it does highlight how the dissection of first principles can lead away from reality. Physical model 0, universal principles 1. Well, it was worth a shot. Yet all is not lost. We can still look under the hood of the Born rule. In contrast to the conservation of energy, the Born rule was distinctly new for its time, with lots of juicy metaphysical implications and conundrums. For example, it encompassed the new idea of quantum superposition, that a single particle can possess different states, such as spin up and spin down simultaneously. It was so revolutionary that even Schrödinger of equation fame had trouble with the Copenhagen interpretation of it, and he proposed a Schrödinger cat thought experiment to counter it. Poor kitty. Fortunately, no one had the heart to carry out that experiment. Instead, John Stuart Bell came up with a more humane thought experiment in 1964 that could decide, among other things, the controversy between one state at a time versus simultaneous states. Stuart Friedman and John Clauser carried out the first experiment in 1972 using photons and their measured polarization. It confirmed that hidden single states that persist in time, in other words, local hidden variables, was indefensible. Applied to more classical properties such as momentum and position, given a prior measured momentum of a particle, we cannot know with certainty what the exact position of the particle will be down the road. Even more extreme, current position and momentum cannot be considered the sole sufficient causes of a single future state. Yikes! The world is not clockwork. Determination 0, indeterminism 1. The Born rule also encapsulates the idea that each state evolves according to classical physics, independent of each other until something extraordinary happens. For example, in a Mach-Zehnder interferometer setup, a single photon can be thought to travel both possible paths at the same time, according to the classical rules of reflection. One phantom photon, highlighted in yellow, would travel straight through the first beam splitter, bounce off the bottom mirror, and head toward the second beam splitter, where one would assume either detector 1 or detector 2 would pick it up, 50-50. Likewise, the other phantom photon, highlighted in blue, would reflect off the first beam splitter, bounce off the top mirror, and head toward the second beam splitter, where one would assume either detector 1 or detector 2 would also pick it up. Those assumptions will be correct in almost all cases. Green highlights those portions the two phantoms share. Both detector 1 and 2 would receive the same number of photons in an extended experiment with multiple photons. However, in one very specific case, only detector 1 would receive hits. When the paths are exquisitely fine-tuned to exact lengths based on the photon's wavelength, the photons can interfere with each other to erase the path to detector 2. Detector 2 would be left out in the cold. That is when we see quantum mechanical effects that defy traditional physics. It is almost as if existence itself is a storm wave traveling on a vast ocean that occasionally comes crashing onto human shores. Even weirder, when we try to shine some light on the situation, the quantum effect disappears like a moon shadow. Going back to our diagram example, if we were to turn on the red sample box at the top to try and get a peek into the proverbial black box, the classical behavior returns. Back to 50-50 between detectors 1 and 2, and a new 50-50 between the red sample box and the detectors. Granted, when we observe, we get to dive under the comforter of our classical world, where objects don't split into virtual phantoms. However, it leaves us with a quandary that what is going on behind human reality is at complete odds with human reality. There is not a single object behind the scenes, just a bunch of phantom objects like halos of things. Realism 0, anti-realism 1. We have yet to get closer to a single objective reality. If anything, we are getting colder in this game of hide and seek. But there's no reason to despair. We can still lead our horses to the pool of quantum interpretation to draw a nice cool drink. So far, everything covered has not addressed how the quantum world and human reality play together. The Schrödinger equation only explains how the unobserved world misbehaves. There is nothing in it that explains how observation affects this world, or how quantum stuff condenses into an observation. And the Born rule models how the fantastical probability states of the quantum realm evolve, but it does not model how this fuzzy underlying non-reality rolls its dice, or even how our deterministic world spits into the underlying quantum mush. This is where interpretation takes the field. The Copenhagen interpretation and other interpretations do directly address these issues among other important things. Quantum physics hasn't left us out in the cold, at least not completely. The Copenhagen interpretation, which Niels Bohr and Werner Heisenberg, physics odd couple, co-developed in the 1920s, pushed aside many of the nagging issues that were blocking physicists from doing their calculations. In a nutshell, that hardly does justice to the diversity and efficacy of the Copenhagen interpretation. The Copenhagen interpretation lays out how quantum phenomenon and human reality get tossed together. It is a big pot of quantum gumbo soup with the following eyeballed recipe: a dash of Schrödinger's wave function, a pinch of the Heisenberg uncertainty principle, a splash of a wave function collapse, a block of classical measurement results, a dollop of Born's rule, a knob of wave particle complementarity, a scant of quantum world inaccessibility, a heaping of correspondence between classical and quantum properties, and a sprinkle of pixie dust. Bake at several degrees Kelvin for just under 14 billion years. Interestingly, both relativity and quantum mechanics can be scaled up to universe-sized proportions with varying degrees of success. Talk about something beyond human comprehension. To place it back into teaspoon portions, one of the things the Copenhagen interpretation describes is how the fluctuating quantum world, which is pre-observation or even non-observational, randomly transforms into the reality we all observe, and how reality feeds back into the quantum world. It is like picking a potential winning ticket out of a bag, but it doesn't become winning once and for all until we look at it. I keep trying that with my once-a-week lottery ticket, but I must be doing something wrong. This is in contrast to Einstein's relativity, which explains how to transform one observation or point of view into another, and still see the same thing happen, where no one particular observation is given priority. The feat is apparent in the twin paradox, which is neither paradoxical nor mystical once it is understood. For quantum mechanics, the transformation of many unobservable quantum states into a single observable actual seems almost causal in its squeezing of the wave function into a single eigenstate. and at the same time seemingly surreal, a mixture of fact and fantasy. However, very few esteemed physicists would maintain that any part of the Copenhagen interpretation describes an underlying reality, or posits any new object, such as an existing wave. And rightly so. The goal of physics is not to entertain us with idle underlying metaphysical speculation, but to provide the groundwork for doing hard science, with some fun thrown in. Even still, there are subtle shifts in our metaphysical models that quantum interpretation forces upon us. For example, observation and observers are no longer separate and passive from what is observed. We are no longer an empty vessel just waiting for perceptions to feed into our consciousness unaltered. The act of observation, choosing to observe, has consequences in the real world that affect what we and others see. In particular, once a single person, Alice for example, observes Schrodinger's cat to be alive, the wave function collapses, and mere observation by other people cannot alter that fact. Our eyes have become active participants. At this point, I hope no one would be motivated to take their quantum frustration out on our cat after he had survived. Cats always get revenge. Interestingly, whoever observes is not important as long as someone observes. If Bob had done the observing instead of Alice, the cat could also have been determined to be alive, or dead. And it could have easily been Ted or Carol to do the seeing. In addition to observation, a classical experimental apparatus needs to be present, to act like a spiritual medium to bring one of the quantum spirits into our world. Let's put the experiment into a storyline using a gentler catnip aroma instead of poison gas to see how observation and experimental apparatus come into play. Also, let's have an on-off switch for the experimental apparatus on the outside of the box. Let's begin. Alice places a 100% normal, non-high cat, let's call him Shasha, into the experimental catnip box. Radioactive decay is still the trigger for our more humane catnip snuff. The lid is closed. The conditions are ripe for quantumness, but it hasn't seeped into human reality yet. In order for that to happen, the hidden experiment must be turned on, which does trigger quantumness. Shasha immediately fades from 100% normal to simultaneously being normal and on a catnip high, which likely would be indescribably trippy. Believe it or not. The technical term for this state of affairs is quantum superposition, but I like the imprecise term quantumness since it does connote weirdness, even if it misuses the original meaning of quanta. At some point, the experiment is turned off. The double-state quantumness perseveres in parallel, but the probability of getting a high or normal cat does not change. Then Alice, Ted, Carol, Bob opens the box and collapses the wave function into a single state. Someone will observe a 100% normal or a 100% high Shasha. There are no halvesies. And finally, anyone else who looks into the box after the initial observation will see the exact same thing even after the lid is closed and reopened. Once a classically happy Shasha, always a classically happy Shasha, unless someone does something unwise to re-annoy him. From this hypothetical, we can see that 4 classical movements may have quantum mechanical implications down below. Closing the lid to high Shasha, turning the experiment on, turning the experiment off, and opening the lid to observe Shasha. In short, the wave function must somehow be connected to the experimental apparatus and the observer, whatever and whomever that is. We are all connected. I can see why mysticism and quantum mechanics sometimes get entangled. And don't forget Shasha, who does have laser eyes. Shasha was the name of my wife's childhood cat, by the way, who died at a wise old age. To get allegorical, it is as if unobserved quantum phenomena can gobble up unsuspecting classical stuff and create a larger wave function, if we don't keep an eye on it. Maybe humans are creating overlapping atolls of reality in a sea of uncertainty. Or it could be like innumerable waveform screensavers which bounce around the screen interacting with the walls of the monitor, instantly communicating with each other about what they detect. Also, it is as if the experimental equipment and the cat can detect when someone is peeking, like the funny sensation we sometimes get in the back of our heads when we feel someone staring at us. "Why are you looking at me?" In reply, "Because you're looking at me." It is maybe like and as if a little bit of so many different things, and yet unlike any one thing in our experience. So how could it be real? See what happens when reality is shattered into pieces? Especially since classical reality tells us that a wave can't be a particle and vice versa. At this point in the path, we just have to accept quantumness and keep moving. What is one more duality to choke down? Given that we may have the final answer to the universe, but we are just not quite ready to comprehend it yet. Paradoxically, some founders such as Schrödinger initially tried to frame quantum mechanics in little r reality. Just because a person molds an idea doesn't mean he gets to control its fate. An idea is born, and it takes on a life of its own, growing and evolving in unpredictable directions. For example, one can make the case that quantum reality is like an immaterial spirit, hovering among and above bodies, although that would probably not be an acceptable analogy or model for most physicists. Even so, some have taken on that uphill road. Mind over matter. Personally, that seems like a dead end, but who am I to criticize those who explore their passion? Despite Heisenberg and another quantum physicist, Max Born, declaring at the Solvay conference in 1927 that quantum mechanics was complete and irrevocable, the Copenhagen interpretation was just a starting point in a race that is still being contested as of today. It was just a framework to place the wave function in, to give it context, so that existing phenomena could begin to be placed under its umbrella. In order to get the ball rolling, Bohr and Heisenberg provided lectures throughout the world, and they showed how to successfully apply it. Nothing succeeds like success, and good marketing. Still, success depends on more than technical competence in a flashy marketing campaign, even though that is often the only focus. The general adoption of any revolutionary, enlightened idea requires that it appeal to many levels of human consciousness, even if it goes against everyday common sense. It must be made to resonate like any good story or song. It must inspire and produce awe. In the next video, we'll take a look at how something similar happened with Newton's 3 laws, albeit more in line with the 3 principles of realism that are presented in these videos. As for the Copenhagen interpretation, there are many strong resonances. They go back to our primal philosophical roots. And like the Copenhagen interpretation, it is a bits and pieces sort of affair, like trying to piece together the shards of glass left on the floor, when reality's window was shattered. Or maybe even a little bit like Humpty Dumpty. For example, there is a Pythagorean relativism in which man is the measure of all things, the Heraclitean perpetual flux underlying human reality, the Parmenidean one being which possesses all qualities at once, the Platonic duality of reality and appearance, and the Aristotelian, I think I put too many T's in there, juxtaposition of potential and actual. I could go on, but it's like beating, in quotes, a dead radish. Hey, we are animal friendly here. And sorry for the pun, beats are not verbs. These all resonate with our armchair philosopher. That is not to say that quantum mechanics fully adopts any of these metaphysical positions. Rather, each position is grounded in something that makes some metaphysical sense, whether that be an argument or an observation. And when dealing with something that makes no sense at all, we need all the security blankets we can get. One-stop shopping is essential when we don't quite know what we will need or want. Any successful scientific theory is a child of its place in history, both scientific and philosophic. Each with its good points and bad, each with its groundbreaking ideas, and each with its boundaries and limits. Science is not some absolute truth that can stand alone. No matter how we try to disguise it, science and philosophy go hand in hand, like the weft and warp in a fabric. I doubt it was a conscious decision on anyone's part to pull so many diverse ideas together, both scientific and philosophic. It probably just felt right. It is similar to solving the final surprise answer in a word jumble puzzle. You know when you have the right answer. I like my puzzles simple, and my solutions even simpler. Jumble fits into that category. Crosswords do not, but that is just me. If we pull back and look at the entire city block instead of a single brick, the Copenhagen interpretation is like converting infinite different dreams into a single reality. However, dreams are what are meta-real, if there could be such a term, and human reality is the illusion. Even worse, human reality appears to have been misleading us as to what the behind-the-scenes world is really like. Despite the overwhelming success of quantum theory, the big hole of a problem is that we really have no clue about what is going on, how the conversion of potential into actual happens, whether it does really happen as an event, or even if we can discover anything about it. Pay no attention to the wave function collapse behind the curtain. It is like the wispy luminiferous ether that so many classical physicists were convinced existed because it must. but never went about testing that assumption until the Michelson-Morley experiment. Talk about a gut punch. So current physics is in a near impossible situation. We know that something weird is going on, and that we can model it mathematically to near perfection. However, according to many, if not most, interpretations of quantum mechanics, our imagination is in theory incapable of grasping quantum reality, or even physically modeling it. And it is not about having enough precision, a better microscope, even though we often think of the quantum world as confined to the microscopic. We cannot see or experience firsthand quantumness, even if we were staring it straight in the face. Our brains are just not wired to deal with it. We make the denial palpable by accepting quantumness, whatever it is, as truth, as a true description, and by turning our back on classical objects, in other words, single well-defined objects with innate properties. A negation of reality in favor of truth was also common to relativity, if we remember the point about space-time. So at least the two camps are on the same side of the fence when it comes to theoretical constructs and greener grass, even though Einstein was a realist and almost everyone else was not. Truth 1 being 0, or if you prefer more philosophical terms, epistemology, the study of knowledge, wins over ontology, the study of being. However, that goes against simple everyday metaphysics. That is not to say quantum physics denies the an object exists principle, which was presented in the first video. For example, I would guess that the majority of physicists would say that an electron exists. We are fortunate that the sun does not go to sleep when it sets. Instead, quantum physics undercuts a more esoteric corollary of this principle that has yet to be stated or explored in these videos. The corollary is properties define an object. This corollary is at the union of little r reality and the infinite unreal. At this point, we are still barely off the ground with little r reality. Consequently, we are just going to have to wait patiently for an examination. Still, the fraying of this union is what drives the emphasis on truth and the disregard of being. If we are to take quantum metaphysics to its logical conclusion, intrinsic properties which define a thing exist independent of that thing, as wispy as a cloud. For example, an apple's biting crispness, if it were a quantum property, could be said to stay partially in the fridge when I take the apple out to eat it. And if your brain hurts too much trying to ponder the quandaries of quantum mechanics, just repeat after me. It is a theoretical construct. One more time. It is a theoretical construct. Move along, nothing to see here. In other words, there is no need to worry ourselves over metaphysical questions. It all works in the end, so why bother trying to get to the why of quantum mechanics? Feeling better? So even though both positions are contenders for objective truth, not boxing, and both place their bets on theoretical constructs, the big difference between Einstein's view of reality and quantum mechanical reality are in the metaphysical building blocks, which generate fundamentally distinct realities at odds with each other. For Einstein, the conceptual building blocks are timeless, deterministic laws driving the universe toward an inevitable end, whatever that may be. It is the job of physics to hunt for, find, and formalize these treasures. As such, the reality of big R reality, which many equated to ether, was properly put out to pasture. However, time has been reduced to a fourth spatial dimension, and the resultant space-time abstraction remains firmly attached to the infinite unreal, from which no extrication into little r reality is possible. In contrast to relativity, the theoretical building blocks for quantum mechanics reach even higher levels of abstraction. They are mathematical phantoms, distributed in a probability cloud, which our wetware is ill-equipped to know with any clarity or directness. Human reality is no longer an imperfect approximation of the quantum world. Instead, it is a Hollywood illusion, heavy on special effects wizardry. As a consequence, quantum interpretation has the unfortunate side effect of dissolving the reality of things, of casting little r reality outside the scope of physics. These probability clouds, which physicists call quantum fields, have been substituted for physical objects as the fundament of the quantum world. Properties have been disassociated from objects and given a new home in mathematical spaces. 17 to be exact, each one associated with a particular particle of force, neatly summarized in the standard model. At least for now, more quantum fields may be coming. Or not, it is still up in the air. If we are to couch this approach in our current realist metaphysics, These fields are equivalent to 17 infinite unreals, overlaid each other, cohabitating. If mathematical objects can even be said to cohabitate, I hope to show that this approach contains an inherent contradiction, and is a bridge too far, or rather it is a bridge that has not gone far enough. What God hath joined together, let not humankind put asunder. It is easy to see why Einstein was hesitant to give in to quantum theory, even though resistance was futile. Einstein's world was fundamentally determined, while the quantum world was fundamentally haphazard. In the quantum world, laws are more like guidelines rather than hard lines. Interestingly enough, it is quantum field theory which holds sway in the court of scientific opinion when characterizing our world, mainly because quantum theory survived Einstein's deterministic assault, and because quantum theory is crazy accurate in making predictions over many rounds. This despite quantum mechanics having yet to completely merge with general relativity, or vice versa, depending on your preferred starting point, winner take all. It is this disparity between human reality and quantum phenomena that has brought on a philosophical conundrum in physics, and that has left many doubting little our reality. By the way, all perceptive images are illusions, or more accurately, constructs, even ones of reality. However, that does not negate the realness of things, but that paradox is for another day and time. Another day, another Doug. Kudos to director Taika Waititi for voicing Korg. So as it stands, we have two tracks of mutually exclusive laws based on scale. One for the miniature, i.e. quantum mechanics, and one for the relatively large, namely relativity. And never the twain shall meet. Unfortunately, the infinite unreal being singular and the principle of relativity demand a single set of self-consistent principles and models. This town just ain't big enough for the two of them. As a start to finding a resolution to the unreality of quantum phenomena and the abstract reality of relativity, the second video in the current threesome will focus on events and how they serve as one of the pillars of little r reality. I am hoping to show that we can no longer take observational sameness as an unconditional gift, that it is a continuous ongoing event involving physical objects. We cannot rely on aging first principles, their manipulations, their interpretations, or their current metaphysics. Our old toys just won't do. In turn, I will argue that physics needs our old metaphysical dogs trained in new ways, now more than ever, to make progress. We must dig deeper than laws, space-time, quantum fields, probability distributions, and eigenstates as substitutes for reality. They help us understand reality, understand its patterns and predictability, but they have limits. We will need to use metaphysics to guide us in redefining reality founded on new objects and new events. Finally, relativity's dismissal of big R reality and quantum mechanics' dismissal of physical objects does not free us from having to explain objective reality as an event, and not just as a psychological one, although there is that aspect to it. We are not living in a hidden totalitarian state where some evil autocrat is spinning a false history we are forced to consume. There is more to it than that. We have so much to discover if we just allow ourselves to press a mental reset button. If we allow ourselves to go where we dare not go. Well, it's time for a break. The next video will explore events and begin to show how we infer a past occurrence using rules and a current state. It will lead us into insights of how human endeavors progress in general and how fundamental physics could take its next step, at least with regards to its conception of inertia, the other side of the relativity coin. Shoot, reality needs a walk.